Today I'm going to show you a very simple way of how a physical representation and a logical representation of what we call the mesh topology. It is a very difficult system to troubleshoot, but it's also easy to troubleshoot on the other hand, because it is basically devices being connected via one another and in or like a spider web, back and from. Everyone will have to communicate. So if there's a single point of failure at this end here, between here, you can route the data from here and back here, because there's a breach between here that have been caught. So you have a unique switches that have the level multi-layer switch here. I got 4. You can have as many switches as you want to use, but I normally like to use this switch because it's very good to use, because it is being managed already and it is just a single drag and drop. So let's quickly start the ball rolling. So you go and find a cable, and I'm going to use what we call crossover cable to connect these PCs, not PC but my switches. So like I said to you, we'll just use 4 switches. Sit back and relax while I do the drawing and I'll do the explanation. So this is a representation of, for example, you have this data flowing from here going this way, and you also have this coming. So they are interconnected to each other. So now you see there's a data being transmitted from one end to another, connecting these switches together. So we're going to have a cross point from one end to another. So we'll take from this switch to this switch, and we will take from this to this. So we'll come back and use similar cable. Click here and connect it this way. And lastly here and here. So this is it. Very simple to do, but it is difficult to understand. But if there is a cord between either of these points, if there is a cord here, it means that data sent from here can route all the way through here and come here. If also there is a cord here, data also route around to go from one end to another. So this is a full mesh topology. It is not a half. Half is normally maybe you only have 3 or 5, something like that, switches. So now we're going to join our PC. So we'll go and collect laptop. I'm going to use a laptop in this exercise. So laptop 1 will come here, laptop 2 here, like that. So we'll have our full laptop, which is okay. So each of the laptop will represent different countries. So I'm going to put here, I'm going to put Europe. Let me say Berlin. This is Berlin, and here will be India. And we see Africa. So these laptops are representation of different offices across the globe. So we will join this laptop using different cable. We will use the straight through. So from here to this, hook it up. So we now have 4 different countries being hooked up on the internet. So this office, India can troubleshoot or can send data from here all the way through here without going straight. Either you go this route in different forms and manner. So the next thing now we're going to do is to assign IP addresses. So we're going to assign our first IP address here. So desktop, and we use static IP address like I said to you in the previous video. I'm going to copy this because of my default gateway. So drop it. That is 16.1. And we'll have our, going to change it to 16.10. It's already standing there. Go to the next PC. Make this 12. Finally, on the last machine, we'll make this 18. Completed. So we now have our 4 countries all being represented here at each laptop. So we can run a pin command and see the data flow from one end to another. So let's do that. So this IP address is 14, and this is 18. So we ping from here. Command line. So we'll say first we'll say IP config and see which machine we are on. I normally like to do this. Okay. Make this big. So it's so we are on 18 and we want to ping the first machine 16.1. So we say ping (68). Oops, 68.16. Now if you ping this, you see it runs perfectly. We send a full packet, and all of the full packet that we sent were received quietly. As you can see, we send full packet, and it means that they are communicating with one another quietly. So we're going to test that also and see by sending a packet from here, drop it here and here. So if you look beneath here, you see it being successful. And if you also take data from here, to this point. You also see successful, just like that. That is how we run our packages and test as to whether we have a connection from one point to another. So they are all being set and running. So if you look at stimulation here, it should run perfectly for you to see. So real time, and if you go back, you'll see the packages being breaking down. So come here, grab something from here too, and back up here, you'll see the data running. So that is how you can do this logical settings in Mesh Topology. So if there's a cord between here and you send the data, you will notice. So let's take, for example, let me see what I can remove this cable. Let me remove that cable and see something. Oh, if you remove any of the cables, it will become a half stock. So let's show the physical. So you see here, home city. So if you rename this now, maybe test, for example. So this city is called test. So if you double click here, these are a PC hookup. Here are the devices that we connected. And this is the 24 port switch that we use. That we did all of our connections on. So if you can see in here, we have everything set and running. So thanks for watching. Make your comment and share this video and recommend this to your colleagues. So that is how we can normally do. So these are all of the cables and connections that we use here. These are the things that are displaying here. All of these cables are on these switches. The ports are made available on these switches. So share this video. Thank you for watching. Watch out for our next video coming up.